So I'm Jatin Bhadra. I used to be a Java developer, but nowadays I tend to spend more of my time in automation space, trying to get all the release automation, build automation, and areas around that polished up and implemented. And that is where my experience around Maven and continuous delivery has come. And I want to share one of the challenges that we had on our project and the solution that we have put in place around that challenge. Let's set the scene in terms of what we are dealing with. Essentially, here in this project, we got two applications which are broken up into various web modules. Each of this web module is developed as a Java web module and packaged as a standalone WAR file that is deployed in its own container. So each web module is deployed in its own container. Underpinning these web modules are a bunch of common components or common modules, which are essentially Java jar files, which are consumed by these web modules. Now, not all of the common jars are used by every web module. There is a subset of jar that each web module needs, and using Maven and Maven dependency tree, web modules define the common jars that are needed by a corresponding web module. The development of web module is like mixed. Some of the the development of common jars is sort of mixed in terms of with the teams that develop it. Some of the common modules are developed by same team that is developing the web module, whereas there is a dedicated team that develops a subset of these common jars. Our CD pipeline is fairly standard, simple stuff. We have got the source control system. We have got the build system that does all the quality analysis, static, dynamic, test execution, packages the code, and based upon what package is produced, whether it's a web module, then automated deployment is kicked off and it's deployed to the target environment. If it's a common module, then it's a jar file, in which case it is booked into Maven repository, Nexus being the repository in this case. So the challenges is essentially around how do we manage versioning of these these common jars. So the life cycle of common jars and the web module is sort of independent of each other. The frequency of change would vary depending upon the requirement. So the change to the common jar could result as one application requiring something to be changed or another application, in which case both the applications don't necessarily want to consume the latest change in the common jar all the time. So in the early stages of development, obviously the frequency of change of web module and the common jar is very high, in which case the developers always want to pick the latest version of the common jar to be used in their web module. However, at the same time, the developer doesn't necessarily want to manage versioning of the common jar or the web module. When I say that, I mean the developer doesn't want to go and change the POM file version of the common module, check it into version control system, generate a build which will give them a version build of common jar, and then go and change the dependency in the POM file to depend upon the new version of the common jar that has been booked in Nexus. That is an overhead. It's probably unnecessary overhead that the developer will have to do that all the time, and they're probably going to forget to do that. The second requirement is that after a certain time, when the web module has reached a certain stability, they don't want to pick the latest version of the common jar automatically. They want to make a conscious decision when to pick the new version of the common jar that has been released. Because the change that would have been done to the common jar could have been for another web module, in which case the stable web module wouldn't be interested in that change, at least straight away. The third requirement is that all the builds that are done for the common jars and for the web module need to be traceable, that is back to the source code version that had built those jars and war files. And then comes the continuous delivery principle, whereby any build that we do could be a potential build that could go in production. So summarizing all these 4 requirements, essentially the first one, whereby the web module developer always wants to pick the latest version of the common jar. The default answer that Maven gives us is to use snapshots. Yeah, use snapshots and make your web module dependent upon a snapshot build. A new build of common jar is produced, a new snapshot is available, and automatically your web module build is going to pick up the new snapshot. That is okay, but it produces some challenges. Let's look at this 4-week cycle, whereby in week 1, for a common web module, which is foo jar in this case, a snapshot build was done. A 100 snapshot jar was produced. In the same week, a web module A, which was using foo jar snapshot, was built, and that resulted in a war file. Now, at this point of time, at the end of week 1, we are confident, or we are relatively confident, that if we need to know which is the source code version that has been used to build foo jar, then that is going to be the latest version in the version control system. However, in week 2, there is a small change that has been done to foo jar, and a new version of, or a new snapshot build has been produced for foo jar. Web module A hasn't been rebuilt because web module A is not interested in the change that was done to foo jar. So at end of week 2, we are not so sure which version or where is the source code of foo jar that is packaged in web module A, because that was previous version, not the latest version. So if for some reason there was a defect found at end of week 2 during a sit phase of web module A, it will become slightly challenging to find out. There are ways, maybe by using timestamp, etc., on the jar to find out which version it is, but that's not 100% guaranteed, and it's a little bit tricky to do that. And using continuous delivery principle, if by some means this war was great and it was to end up in production, then we now have a snapshot version running in production, which is not good. So what is the solution? The solution is not to use snapshots at all, but to produce a version build every time. But then what about the overhead of developers having to do the versioning of common jars and then having to change the dependency in the web module? Well, use automatic versioning or dynamic versioning in Maven so that it produces a version for you automatically. How did we go about doing that? Is by using a variable in the version name itself. So a schematic versioning, major, minor bug fix. So replace the bug fix with a variable. The variable is called revision. So in the common modules POM file, rather than having a snapshot, this is the syntax, or this is what will happen, or this is what will be in the common modules POM file, 1.0.variable. The value of this variable is replaced, in this case it's subversion, so it works well, with the repository revision number, which is a long number that your repository revision is at that point of time, and that value is replaced by your build system. So using Jenkins or TeamCity, whichever is the CI server that you might be using, just add -d revision and get the repository revision number for which this particular build job is running. So now the jar that is produced no longer has a snapshot, neither it is added as a snapshot in Nexus. It is added as a proper revision, which is 10 repository revision number, a relatively long number it might be, or a short number where you are. And the jar name itself will also have your 10.revision.jar as the jar name. Now, how do you consume this jar and how do you consume the latest version of this jar all the time? Is by using ranges. So Maven now supports the concept of range. So in the web module, rather than having a dependency on a snapshot or on a fixed version, you change So web module A is dependent on foo.jar, and it's dependent on a range which is 100 to 200. The square bracket means inclusive, and 200 curly bracket means non-inclusive. So 200 is non-inclusive. This solves the problem of a developer not having to manage the versions. Your common jars now are always version, because the repository revision number is part of the version and part of the jar name as well. You can always pinpoint which source code version was used to build that jar. In the web module as well, you can pick the latest version if you choose to during the early phases of development. And inside the web module, you can always trace back exactly which version of source code was used to build those common jars. Now, what happens with branching in this kind of scenario? For whatever reason, especially in our case, we have to create, or we do create, a branch after a web module has gone in production, so that any emergency bug fixes can be done in that application support branch. So application support branch can continue to use the 100 to 200 range, whereas any further enhancement for next release that are required, the range is bumped up by major version. So rather than having 100 as a common module's start revision, it will have 20. And so would the range change in the web module that is consuming that jar. So there's still some challenge in this kind of setup when you are doing local development. Obviously, when you run Maven install or Maven package locally, you don't have the variable of repository revision number unless you add that -d attribute, or you configure your Eclipse environment or your IDE somehow. The default solution to that is that in the parent POM of your project, you specify value for your revision variable as snapshot. So this will be the value that will be used when you run Maven install locally. This solution has got a problem, and I haven't really fixed this yet. Any suggestions are welcome. Is that for a scenario where a developer is working on web module and on common jar as the same time, and he does a change to the common jar, and then he wants to do some integration testing with his web module, he can run locally Maven install, which will create a new version of that jar, which by default will be a snapshot build. But when he builds the web module build is not going to resolve to snapshot, because the web module POM has specified range, which means it is going to resolve to the latest revision number that is there in the repository. That is a challenge. Maybe a solution to that is to have a big random number, the max of integer, as a default value rather than snapshot. I haven't tried that yet. 1 minute left. Any questions, any thoughts?
If you have three projects that depend on one another in succession, so you've got like a grandparent, a parent, then a project, and someone updates grandparent, then will there be a new subversion, revision of the parent?
So this question is related to the subversion repository variable, or?
Yeah, if you're using the subversion version as your Maven artifact ID, then what happens if a parent thing changes, but no one's committed any changes to the, if the grandparent has been changed, but the parent hasn't?
So the way in which we structured our repository is for every common module has got a trunk and a branch, and the jobs are pointing directly to the folder under the trunk from where it's got to build. So if there was a change in any other folder, then that change will not trigger the CI build, in which case that repository revision number won't impact. So they will be skipped. So say you got trunk and you got foo jar and you got bar jar, and there were changes to the bar jar which incremented the repository revision number to 3. However, the first build of foo jar was 1, so that was what was used, and next revision number would be 5 if there was a change to foo jar. So the next version that is produced for foo is going to be 105. So there will be 101 and 105. There won't be 103 and 4. Go on.
If you start using real releases for every single commit that you do, your Nexus or Archiver is going to get put up pretty quickly. Any thoughts around that?
Yeah, so I have not tested it fully, but there is a way in which you can delete versions of Nexus. There is a schedule that runs, and you got to just give it a rule whereby it can delete any old versions that have. There are a bunch of rules that can be used to do that.
Those versions might have gone to live. You don't want to delete.
Yeah. Yeah. So we haven't implemented that yet, and your question is really valid. Right now, rather than the challenge of Nexus file system getting filled up, more of my challenge is that the build system and developers machine file system is starting to get filled up. Because of the ranges, the way in which Maven works is, if you specify a range, it is going to download all the artifacts in that range that it can find in Nexus. It's not going to say, okay, here is my metadata, and this is the last version. I'm going to download only the last version. It's downloading all. And even if it is now downloading all, because the repository is outside your build system, you don't necessarily clean up the repository all the time. So every build that has run is going to keep stuff in that local repository. But yeah, your question is valid, and I need to do a little bit more digging around that. We got more challenges with multiple dependencies. So if you got foo jar that is dependent on bar jar, and if foo jar is using a range to depend on bar jar, then that is where it gets really messy.
What about gates? We haven't got any.
I have no answer to that. Okay, if there are no other questions, thank you very much.